Hi everyone, this is Mrs. GA, and today we're going to be talking about the unit circle, and we're going to see if we can use the unit circle to help us evaluate trigonometric expressions. So first, we're going to talk about the unit circle and how to fill it out because you guys are going to see different parts of the unit circle can be really useful for us when we're working with trig expressions. So first you need to know what a unit circle is. A unit circle is a circle that has a radius of 1. The length of the radius is 1 unit. So we're going off that assumption as we fill out all of these values. So first, we're going to start by seeing if we can use kind of logic and work our way through to fill out the number of degrees for each angle. So it's really important that you know that we always start on the positive x-axis right here. We call this 0 degrees. So first, we can look at let's go to the halfway point. Hopefully you know that a full circle is 360 degrees, so I'll put that down here. So if we use logic, we can say, okay, half of that would be 180 degrees. And then we can go, okay, well, half of that must be 90 degrees. I'll put it underneath. And then we can kind of work our way from there. So I see this is 90 degrees. This is half of that, so this is going to be 45 degrees. And the other angles are split up into thirds. So this is a third of the way, so 30 degrees and 60 degrees. Now these the different distances between the lines are the same in each quadrant. So we could say, okay, the distance from here to here is 30 degrees, so that's 120. And then if you look, okay, the distance from here to here is 15, so we add another 15 to get 135. The distance from here to here is also 15, so we do the same thing here, and you get 150. And then look, from here to here is 30. Oh, here to here is 30. So let's see if we can replicate that here. So then add another 30, so 210. Add 15, 225. Add 15, 240. And then add another 30 to get 270. Add 30 to get 300, 315, 330 degrees, and then we're back to 360. So from here, we're going to now fill in a different measurement for a unit circle, which is called radians. So we're going to talk more about radians in the next part of the lesson. But for radians, again, it's a different measurement. We still start here at 0. But this time, a full rotation, we call it a measure of 2 pi. 2 pi radians. So pi, remember, is approximately 3.14. So pi is not the unit, it's part of the measurement, 2 pi radians. So let's see if we can use logic to help us break this down into smaller segments and fill out the radian measurement. So if a full circle is 2 pi, we can logically say, okay, half a circle is pi. So half a circle is pi. Halfway to pi, we would call pi over 2. And then let's look here. Well, we could say these are split into fourths. 1, 2, 3, 4. So we'll say this is 1 pi over 4. This is 2 pi over 4. This is 3 pi over 4, and then this is 4 pi over 4, which is pi. Let's keep counting by fourths. This becomes 5 pi over 4. This becomes 6 pi over 4, which would simplify to 3 pi over 2. So 5 pi over 4, 6 pi over 4, and then this is 7 pi over 4. And then 8 pi over 4 gives us 2 pi. All right, let's see if we can do the same for our 60 degrees. So if we have 60, 120, and 180, we see that this is split into thirds. So we're a third of the way to here, so that's pi over 3. So this is 1 pi over 3, making this 2 pi over 3, 3 pi over 3. This would be 4 pi over 3. Then this becomes 5 pi over 3. And last here we have 6 pi over 3, which is 2 pi. So we were able to split it into thirds and count our way around. Now let's do this last one. So if we have 30, 60, 90, 120, 150, 180, this is cut into sixths. So we'll start with 1 pi over 6. This is 2 pi over 6, 3 pi over 6, 4 pi over 6, making this 5 pi over 6. So some of them are already filled out for us and simplified. And then this is 6 pi over 6. So if I go another slice of pie, it's 7 pi over 6. This would be 8 pi over 6, 9 pi over 6, 10 pi over 6, which would make this 11 pi over 6. And now we have all of the radian measurements of our unit circle. And again, as long as you know that a full rotation is 2 pi radians, you should be able to kind of use logic and what you know about fractions to fill in the rest. Another thing I want you to start noticing is that anything that is 30 degrees away from our x-axis is always over 6, right? Over 6, over 6, over 6, over 6. Anything that is 45 degrees away is over 4. And anything that is 60 degrees away from our x-axis is over 3. And then, of course, the halfway point is over 2. So now from here, we are going to be filling in the coordinates of our angles on our unit circle. So these coordinates, well, this first one we should be able to do because we know that the length of the radius is 1. So I see that this coordinate must be 1, 0, which means that this must be 0, 1. So it will be really important that you memorize these coordinates. So I have a little trick for where to start. So all of these are going to be fractions. They're all going to be over 2. And then we start here. I go root 3, root 2, root 1. So root 3, root 2, root 1 is just 1. And then you do the same but going backwards. So you say root 3, root 2, root 1. So these would be the coordinates for 30, 45 degrees, and 60 degrees, or pi over 6, pi over 4, and pi over 3 radians. Now, once you know the coordinates from this first quadrant, we're going to do the same, except just adjust for any negative values. So this, since this is 30 degrees away from our x-axis, this coordinate is going to match with this coordinate. This coordinate is going to match with this coordinate, and this coordinate will match with this coordinate. The only difference here, if you notice, this is an xy axis still. Our x values are all going to be negative because instead of moving to the right and up, we're moving left and up. So again, I'm going to do this exact coordinate here, except it's negative root 3 over 2, and then negative, and then 1 over 2. Our y value is still positive because I'm going up. This same exact value is going to go here, except x is going to be opposite. So it's going to be negative root 2 over 2 and then positive root 2 over 2. And same for the 60 degree. This becomes negative 1 over 2 and then this stays positive. So then we're going to do the same thing down in this next quadrant. This one is going to match with the other 30s. This matches with the other 45s. This matches with the other 60s, except since we're going left and down, both x and y are negative. So this is negative root 3 over 2, negative 1/2, negative root 2 over 2, negative root 2 over 2. And last, we have negative 1/2, negative root 3 over 2. Now this one, we can see if we're starting at the origin and we go down 1, this is 0, negative 1. And I left this one out. This is negative 1, 0, because I'm just moving to the left 1. And now we're going to do the same. We're going to match up the corresponding parts. So this goes with the other 30 degree angles. This goes with the 45 degree angles. And this goes with the 60 degree angles. In this case, again, thinking of it in terms of an xy axis, we're moving to the right and down. So in this case, our x values are positive, but our y values are negative. So it's root 3 over 2, negative 1/2, root 2 over 2, negative root 2 over 2, and then 1/2 negative root 3 over 2. So again, as long as you know the coordinates for this first quadrant, you can take them and just adjust them for any negatives, but they will be in the same corresponding parts. So again, all you need to memorize are the coordinates for quadrant 1, and you should know the rest. So I do want to give official names to these quadrants I've been mentioning. It does follow in ascending order for when the measurements are getting larger and larger. We call this quadrant 1. We write it with Roman numerals. We call this quadrant 2. We call this quadrant 3. And we call this quadrant 4. One thing I do want to note is if we start using, if we're working with negative angles, we still start here at 0, but we go backwards. So this would be negative 30, negative 40, negative 60, negative 90. So all the order of these, instead of going counterclockwise, goes clockwise, but that would be our negative direction. Same for radians. However, the coordinates are still all going to remain the same. Okay, so one really useful application of the unit circle is we can actually use it to help us evaluate our trig expressions. So if you know the coordinate of a unit circle, which we'll just call x and y, the x value of the coordinate is always the cosine of that angle. The y value of that coordinate is always the sine of that angle. And if you do the y value divided by the x value, that's tangent. Because maybe you remember this, tangent is sine over cosine. And we know that sine is y and cosine is x, so y over x. Now, our reciprocal functions work the same. Hopefully you remember that secant is 1 over cosine, so secant would be 1 over x. Cosecant is 1 over sine, so it's 1 over y. And cotangent is the reciprocal of tangent, so instead of y over x, it becomes x over y. So now I want to talk about why this works. Why do these ratios occur? Why is the x value cosine and why is the y value sine? So let's imagine again we have that unit circle. And remember, a unit circle has a radius that is 1. So let's pick some angle. Let's say we have this angle right here. So the angle from the positive x-axis to this. Again, since it's a unit circle, we know that this distance is 1. Okay, so I'm going to take this and I'm going to turn it into a right triangle, like this. And we know that our horizontal distance is x, our vertical distance is y, which would make this coordinate xy. And again, we're working with this angle. So this all goes back to SOHCAHTOA. So hopefully you remember the ratios for SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if I'm doing sine of theta, I'm going to do opposite over hypotenuse, which is y over 1, which is just y. So that means the y value of your coordinate is the sine of your angle. If I do cosine of theta, which is adjacent over hypotenuse, it's x over 1, which is just x. And remember, tangent is opposite over adjacent, so we have y over x. So this is the reason why in a unit circle, the x value of the coordinate represents cosine, the y value represents sine, and y over x represents tangent. It's simply a right triangle that has a hypotenuse of 1. Okay, so now we're going to see if we can use the unit circle that we just filled out to help us evaluate the following expressions. So the first one is the sine of 2 pi over 3. If you look at your unit circle that we filled out, the coordinate for 2 pi over 3 is negative 1/2 root 3 over 2. So remember, the sine of the angle is going to be the y value, so the sine of 2 pi over 3 is root 3 over 2. Now let's try the cosine of negative 11 pi over 6. So a negative 11 pi over 6 is the same as positive pi over 6. So remember, if we're going backwards 11 pi over 6, that actually brings us to the same angle. You can do that on your unit circle. So then I look at the coordinate for pi over 6, and that coordinate is root 3 over 2, 1/2. And remember, the cosine of the angle is the x value, so this one is also root 3 over 2. Okay, now let's try the same for tangent of pi over 2. The coordinate for pi over 2 is 0, 1. Remember that the tangent of an angle is going to be y over x. So if I do that here, we get 1 over 0, which is undefined. So you're actually going to see that some of our values will have undefined, we will have undefined expressions, and when we start graphing these, you'll see that tangent actually has a vertical asymptote at pi over 2, which is why it's not defined, but we will talk about that later on in this unit. And last, let's do the secant of pi over 4. So our coordinate for pi over 4 is root 2 over 2, root 2 over 2. So I want to remind you that secant is 1 over cosine. So that means it's 1 over your x value. So if you do the reciprocal of the x value, it's 2 over root 2, which we'll just write as 2 root 2 over 2 if you rationalize, which just becomes root 2. So this is one really useful application of the unit circle. If you know how to find the coordinates, you can use it to evaluate the angles from your unit circle. Okay, go ahead and pause the video and see if you can give these a try. Again, find the angle and write the coordinate, and then decide which parts of the coordinate you should use. Okay, so again, the coordinate for pi over 2 is 0, 1. Cotangent is the reciprocal of tangent, so it's x over y, which is 0. The coordinate for negative 5 pi over 6, that's the same as the coordinate for 7 pi over 6. Maybe I'll add that in for you. It's same as sine of 7 pi over 6. If you work your way backwards, you'll land in the same spot. That coordinate is root 3 over 2, negative 1/2. Remember, the sine is the y value of the coordinate, so it's negative 1/2. The 3 pi over 4 gives you this coordinate, negative root 2 over 2, root 2 over 2. Cosine is the x value, so it's negative root 2 over 2. And the coordinate for pi over 3 is 1/2 root 3 over 2. Remember, cosecant is the reciprocal of sine, so it's 1 over y, which gives you 2 over root 3, which you can rationalize, and it becomes 2 root 3 over 3. Okay, so that wraps up our lesson for using the unit circle to evaluate trig expressions. I do want to point out that we will learn other ways to evaluate trig expressions later on in this unit. But for today, thank you for watching the video.